Um, are are you guys participating in the DOE's OTA model? No, you
No,
weren't with that.
yeah, we decided to not participate in this because we viewed it as a distraction, to be honest with you, because ultimately you need to have an NRC license that still hasn't changed. The NRC license is how you can deploy a reactor, so that's why we're solely focused on, all right, let's work with the NRC. While I'm appreciative of the effort, the DOE is putting in, I think it's great. I think we are as a company, I want to prioritize however, like what it takes to get to the market. That's what we're prioritizing. And right now that's, obviously being collaborative with the NRC. So that's what we're focused on.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
of course, the world cannot meet it without America.
that is willing
But
to
we're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation
We need scientists to design new
and
fuels.
focus on net public
We need
benefit
engineers to invent new technologies. We need
over absurd levels of radiation protection,
entrepreneurs to sell those
then
technologies.
we will march towards this.
We need workers to operate assembly lines that hum with high-tech, zero
where we
carbon
have
components.
unlimited prosperity for all humans.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Okay, welcome to another episode of the Fire to Fission podcast, where we talk about energy-dense fuels and how they can better human lives. I'm Mark Hinaman, and I'm joined today by my new friend, Sam Gibson, founder and CEO of Hadron Energy. Sam, how you doing?
I'm doing great. Thanks so much, Mark, for having me on.
Yeah, you said before we started recording that you're in SF, San Francisco, or Bay Area, right?
Yeah, we're in the Bay Area right now, so we've got a engineering office. It's in Redwood Shores, actually right by Oracle here. I used to live in San Francisco, but recently moved to New York.
Okay, gotcha. Yeah. Sam, we met in New York, right? I think we met first at a data center. You may not remember. I remember meeting you, but we met at a
I
data
do, I
center
do remember.
conference. You were exhibiting, right? So yeah.
That's right. I do remember. Yeah.
I hope it's a good memory. I hope I didn't ask you too hard a question. Yeah.
Yeah. No, it was good. I met you at the data center conference and we had a great conversation. A lot has changed since the first time we've met.
Yeah. Well, I'm excited to dig into it.
Mhm.
So for our listeners and viewers, give a quick intro about kind of what Hadron is, what you guys are trying to accomplish. And then I want to talk a little bit about your background before we talk more about Hadron. So
Sure. Yeah. So, hey, everybody. My name is Sam Gibson. I'm the founder and CEO of Hadron Energy. And really, what we're doing at the company is we are building an integral pressurized water reactor, which is pretty widely understood, and we're trying to leverage as much as we can of existing knowledge, especially when it comes to licensing. Given when I started Hadron, I did a lot of market analysis of what's going on in the industry, and it honestly really surprised me that there wasn't a licensed microreactor out there. And when looking at the other types of companies out there, um, what I found was they were mainly focused on advanced coolants or exotic fuels. And while exciting, I thought, well, there has to be a better way to get to the market more efficiently. And ultimately, that's why I started Hadron. And ever since we've incorporated, like a year and a half ago at this point, we will now be actually a publicly traded company coming up first half of Q1 2026 to make us the first publicly traded light water microreactor out there. So really excited about this. And obviously I'll get into all the dirty details shortly.
yeah, nice. Well, Sam, did you start in this? Surely you didn't start in this just right out of school. Like, what's your background? What'd you study? What'd you do
Mhm.
before you got this idea to go and start this company?
Yeah, it's a great question. So a little bit more on my background. Growing up, I'm originally from South Dakota, where we started working when we were 14, and so I've had, that opportunity. I also got my driver's license when I was 14, so I think just from like a working point of view, I feel like I really got a head start pretty early in my life, and um, I knew from an early age I also wanted to be an engineer because I was inspired by Iron Man as a kid, and I was like, I want to be like Iron Man. So I
Yes.
studied mechanical engineering. I got a degree in engineering leadership from the University of Nebraska-Lincoln, which was, pretty close to home, but far enough away to where I could be on my own. Um, and then, yeah, just was very involved in my undergrad. I was very passionate about clean energy, particularly. It's something I thought was very important. Um, and when I started researching all the various types of energy, I mean, nuclear was the very clear winner out of everything I studied because, you look at solar and wind and like other renewables, geothermal, all of these things are, fine, they have their use cases, but when it comes to capacity factor and actual like decarbonization at scale and really making an impact, nuclear is the best option, especially when you consider the fact that it's base load. So yeah, I think really the AI revolution, to be totally honest, really woke up the industry again and said, "Hey, we now need you," and now public support's higher than ever. Um, so it really came down to just like being very curious about the industry, studying it very hard. Um, I was, part of a fraternity, Beta Theta Pi, in my college days, and I also uh, founded the American Society of Mechanical Engineers student organization on campus there. Ended up getting a couple global engineering awards through ASME, and that's how I really actually started to get connected with a lot of amazing engineers that are much more accomplished than I was, like at the time, just networking. And really, these types of contacts is how I started Hadron. But, you know, after graduation, I had the opportunity to work at a startup before this that was an actual, most of my background's in HVAC. So growing up, that's what I mostly did, commercial HVAC. And yeah, after college, I knew I wanted to start a business, but I felt it wasn't the right time to start Hadron because I had my senior thesis on the subject of basically what Hadron is today. So I just thought, well, why don't I get my entrepreneurial skills elsewhere? So I helped start a HVAC and plumbing service business that was quite an interesting experience. And it, I felt like gave me what I needed, the perspective I needed in order to actually build a company like Hadron. It grew from 0 to $4 million in revenue in less than a year. It expanded very rapidly. And at a certain point, I just thought to myself, I need to go chase that big thing. And that was Hadron.
So did you end up spinning that off or selling that business? How, how'd that work?
Yeah, so um I was like a minority or owner in the business, but I didn't really see much, from like they're still operating, and it's more so like I kind of just moved on. I wanted to just focus on what I'm doing now, and like, you know, it's honestly, I think it's growing. I think they're doing really well. But yeah, I didn't have like a lot of skin in the game there, I guess. So
Yeah.
yeah, it's more so like me starting Hadron was now I can control the destiny, of my career. I want to build something really large, and as we've, kind of been chatting about, we have a upcoming public listing that's valued us at 1.2 billion, um, with the capital, of course, that we have coming in. So, I mean, that's a pretty amazing upgrades. So I'm really excited about it.
Yeah, absolutely. We were doing 4 million a year in revenue, and now we're at $1 billion company. So,
Yeah.
um, dude, fun to hear about, your early work experience. I mean, I empathize, and even like, yeah, I grew up working for my parents and working at a young age, and it's like an extra half decade to a decade of work experience that a lot of people don't get. So, I mean,
Mhm.
if folks are looking online, like you're not that old, like, but you're doing big things as a young guy, which is inspirational and ambitious. It's awesome.
Yeah, absolutely. I agree. I mean, it's just something I've always had the big thinking perspective, and I can appreciate, hard work. I think it's fun, honestly. Um, you know, especially when the mission is important. I think Hadron's mission is very important. I want to decarbonize as much as we possibly can, and like eventually have a counter on the website showing how many like metric tons of carbon that we've saved from, our deployments.
Yeah.
Yeah.
What's the name mean? Why did you pick Hadron as a name?
Yeah, hadron, it's a physics term, so it's a collection of quarks. It's subatomic particle. They have very strong intermolecular forces. Yeah, basically they're everywhere. So I thought, well, looking through, various physics terms, I thought, well, I want our energy source to be very strong and resilient, and I want it to be everywhere. So that's why I went with Hadron Energy.
That is that is nerdy, man.
Yeah.
I love it.
Yeah. Well, and the Hadron Collider also is pretty cool. Like that's also an inspiration for me. But
And for those
yeah,
unfamiliar, what's the Hadron Collider?
yeah. So this is like a fusion um kind of experiment. And to be totally fair, I'm not like an expert in what they're doing there, but like I've done some high level research. And what they do is instead of splitting the atom, they're like forcing them to collide with each other. Um, and it's really interesting. And I'd have to look at like what they're up to now, but that's as far as I know right now, as far as like their
No worries. Yeah,
focus.
yeah. Okay, so let's talk about the tech a little bit, and I think that'll help guide some of the additional conversation. But like
Hmm.
high level, what can you share with us? I mean, light water reactor. Are you guys using the standard fuel? What's like the size of this thing designed? And uh, yeah, as many details as you're happy or willing to share. Give us kind of an overview about the tech.
Yeah. So this is a core part of our strategy is trying to use as many things as we can that are already existing. And the most important is the fuel. So we're using low enriched uranium plus, Lu plus, enriched between 5 to 10%. And we've got suppliers here that are capable in the US to supply this. And in terms of the size itself of the reactor, it's approximately 2 meters in diameter and about 10 meters tall. Um, and yeah, we're working on the balance of plant as we speak. So the steam turbine and generator, these are all kind of like the main priorities at the moment. But in a way, like our design is not really anything super exciting. And that's how we want it. We want it to be very, very simple because the whole approach I would like to have is I want the everyday person to understand what this reactor does. At the end of the day, it's just a fancy way of boiling water to produce carbon-free power.
Thanks. Yeah.
Yeah.
Um. But yeah, if any of this is too specific, like back
No,
me
that's
up.
okay.
You guys, is it? I mean, pressurized water reactor. You got like multiple coolant loops, I assume, then, and it's all water and c- like. I'm sorry, you said the dimensions. Uh,
Yeah,
can,
from my understanding, I'm pretty sure that we have two coolant loops. But to be fair, I would want to verify with our engineers. So this is from what I know right now. Um, it's meant to be uh, it's meant to be obviously modular, meaning we can have multiple reactors in a single uh, like suppression pool, containment pool. So what we're thinking is, and if you look on our website, you'll see that we've got this massive pool of water, and you can line up like 10 reactors in one building. That means each building can produce about 100 megawatts. And this gives us a lot of flexibility in producing anywhere from 10 megawatts all the way up to 2 to 300 megawatts of power for, a pretty wide use case, because we're talking to data centers that need 10 megawatts. We're also talking to some that need like a gigawatt. So it's pretty interesting.
Yeah. Yeah, just logged on to the website and it looks like, I mean, you scroll down, super, super cool graphics, but you've got this thing submerged in a pool. Uh, and you'd have like
Yeah.
multiple reactors then in the pool.
Yeah. They can have a shared containment pool.
Okay.
Yeah.
Gotcha. Do you envision this like having, I mean, truly modular, right? Like
Yeah. Very modular.
several of
We,
these reactors that you can drop in place.
we basically want to have this be completely standard design that we can just mass manufacture. Um, of course, the visual is like we want to have a gigafactory for the Hadron reactor, and the demand is so incredibly high for power, as you know, right now. Like we cannot keep up. Even if we had reactors, like they would be sold immediately, and we'll never be able to keep up with the demand. Um, in the early days, even just like the early specs that we had, we would have customers come to us and say, if you had any reactors, we would buy them all off your shelf. And like we got that from many different people. Um, so it's going to take a little while for us to like build up, the capacity. Um, but we're targeting our first deployment to actually generate revenue by 2029. Right now is our target.
Nice. I guess this pool I mean, having a pool like this is similar to like NuScale's design, right? Like
Yeah, I think it is. I think it's pretty similar. Yeah.
okay. Um, cool.
Yeah. So something for you to know, Mark, is like basically what we're looking to do is however we can, we're looking to move most efficiently to the market. We want to really focus on commercialization. And with all these new frameworks, like the NRC is very much heavily favoring microreactors. They consider them low consequence. We can move through the process pretty efficiently. And especially given that we're a light water design, that's what, you know, makes this whole process much more streamlined for us. So overall, when you look at, all right, here's a reactor technology compared to the others, we are prioritizing speed to market. That's really what we're looking for.
Okay. So what's your strategy then on that? Like what kind of, I mean, you said 2029 be commercial by then. That's awesome. So,
Yeah.
um,
Yeah. So working with the NRC very extensively, we, just had a nice little catch up call with them. We should have like public meetings coming up with the NRC. Before the shutdown, we had more meetings that were scheduled, but obviously we had to cancel and move those. But it comes down to being like very collaborative with the regulator and incorporating their feedback at the end of the day. So if they tell us something about the fuel, like we have to, navigate this way with the fuel, then, that's what we're going to do, because we want to build around the model that can get approved by the NRC. So that's, of course, what we're looking at. And then also getting like early customers is very important. So we're working on multiple different proposals right now, and that will also accelerate our time to the market.
gotcha. Um, so yeah, I mean, with the NRC, like you guys have your regulatory engagement plans submitted. I think I saw an announcement from you that was like, we're posted on the website. Look at that.
Oh yeah. Yeah. So the regulatory engagement plan, this this one needs to be updated, the one that's currently on the NRC's website, and we are working on, getting this updated with the NRC, but we've also submitted our quality assurance program description, QAPD. And then next, I believe, is our principal design criteria. So we're starting to get into some very technical documents, and these kind of take, some time, but luckily we have a really amazing team that on the engineering side can really feed great information into these applications. And then, of course, I don't know if you saw this, but we are working with Andrea Vail, who was at the Nuclear Regulatory Commission for over 30 years. She was a director there, very well known in the industry. So we're really excited to be working with her.
Yeah, so let's talk a little bit about, I guess she's on the team, or she joined your guys' team?
Yeah, so she's right now she's more on the contractor capacity, but she's leading our licensing effort. Given we do have you know Ryan Mott, our director of licensing and operations as well, who drafts a lot of our proposals, and then we have our review team take a look. Um, so it's been going pretty well. Of course, we're going to have a lot of work ahead of us, but that's one area that we're going to be expanding pretty soon is our licensing team. Um,
How
but
how big is the
yeah.
team? Yeah.
So right now we have 14 full-time employees, and then we have a few contractors. We've got plans to grow to about 35 to eventually about 70.
Wow.
Yeah.
That's um exciting times. So,
hmm
um are there key roles or key people that you like want to bring on early? Which, I mean, building this company very ambitious. Which ones? Where do you start?
Yeah, it's a good question. So really, at this point, there's many things that we have to, I mean, if you think about the critical path where we are today, there's many, many critical paths. There's
Yeah.
the
Some of them
technology, there's the
overlap, and some of them
licensing.
have feedback loops, right? Like,
Exactly. So there's a lot for us to plan for. And my job is to bring in the capital necessary, bring in the people necessary. And I think we're well on our way, but really it comes down to the people at the end of the day of who who we bring into the team. And I don't know if you've seen the two most recent hires we've brought on, but Olivia Hand, we hired her from TerraPower, and she's our head of reactor design right now. She has been already instrumental to making a lot of improvements, which has been great. And then we also hired Tim Bussey from Meta. He was he actually got a nuclear engineering degree back in the day, and then worked at many different energy companies, and eventually worked at Meta operating their data centers. So he's got excellent connections, and he's our vice president of business development. And we're going to continue to really strengthen our engineering team. That's going to be my main focus.
let's shift gears, I guess, a little bit to, and we may bounce around a little bit, Sam, but
Yeah.
yeah, that business development piece. I don't remember if it was an announcement or if you told me in person, but like, you guys have locked in some LOIs for like folks that said, "Hey, well, if you had this available, like we would buy power from you." Is that
Yeah, exactly. We had many of these, and to be totally honest, we kind of slow rolled that effort because we could have went crazy and developed tens and hundreds of gigawatts probably of signed letter of intents for this. But what we're really focused on right now is let's focus on getting one to the market and get binding agreements. So we have these LOIs initially, but um, we can actually be very selective with the customers that we're working with, and we're transitioning these initial LOIs into eventually binding purchase orders and PPAs, power purchase agreements.
But that hasn't happened yet, right? Like you haven't converted any of those to PPAs.
That's correct. Yes, we're still focusing on this area, and that's why we're working with Tim. But we're working on some proposals as we speak, and things are things are coming around. So I'm excited to see. Again, we have such high demand. It's just a matter of, all right, who's the best long-term partner? Because there are so many opportunities, as you probably conceive, like where to deploy this microreactor. And for us, it's, well, we're prioritizing sort of AAA clients, if you will. And yeah, we're having a lot of those conversations right now.
Do the AAA clients have like restrictions or their own list of requirements that their power provider has to provide? Like, you guys have color or insight into that?
Yeah, it's always interesting. I believe, for example, like some of the big data center companies, they require like 99 point, I think it's like 4 or 5 nines. So that means 99.9999% uptime or something like this, nearly 100%. And that, for us, we do believe is achievable because say they have a plant that's 50 megawatts and we build in that extra redundancy so that they always have, for example, if they need 50 megawatts, maybe we build them 70 megawatts. And then if we ever have to refuel, we take down 2 reactors at a time and it doesn't affect anything. So that's basically the way that I'm looking at that.
Got it. Yeah. I mean, with new technology, like anytime you build new stuff, there's a chance that it doesn't work as expected the first time, right? So gotta have backup. Why'd you guys pick the 2 megawatt electric number?
Yeah, this was like an early iteration. We're a 10 megawatt reactor. So the 2 megawatts in the beginning was a really interesting like heat pipe take on what we were going for, but now we've pivoted to a much better design that is actually far more economical. And the 10 megawatt design that we have now is very competitive and it fits what the market's looking for as well. So
Was it just total kilowatt hours out that the fuel can do? Like, what were some of the things that made you decide to scale up?
yeah, I mean, really, the decision to scale up came down to like the cost of fuel, for example. Um, we do get some better economies of scale going from 2 to 10 megawatts. Um, Ultimately, it came down to getting a lot of feedback from customers, and we would say, well, what's your optimal size? And a lot of the times they would say 10 megawatts, like this is what they would love to start with, and then just grow in increments of 10. Hearing that more and more over time, just conducting more kind of discovery calls with, people we want to work with. At the end of the day, that's the most important thing is, well, some engineers
Build the
build
product
some
people will buy.
exactly. Some engineers kind of just like build something super great, but then nobody actually buys it because that's not what they want. We wanted to just, do all that hard work up front of what do these people actually want, and then let's just build that.
That's smart.
Yeah,
It's critical and does not always happen in the
that's
world.
right.
So one of my buddies has built several companies, and I'm like, man, have you verified that there's like a market need for this? It's like, no, it'll be fine. It's gonna be so good that people just let it. Which is kind of like the Elon Musk model of, well, just make the car sexy enough that like anyone will drive it.
Mhm.
If you build it, they will come. I don't feel that arrogant to be able to make those calls.
Yeah,
There's no
exactly.
need. Like, yeah. So, um, I mean, fundraising like in public markets, that's gonna be awesome. Like, do you think
hmm
that'll be kind of your only fundraise, or like you have to raise more, or that'll be enough to get your first prototype system going? How are you guys thinking about the funding?
Yeah, so the going public transaction for us, a lot of the information can be found in the Form S4 document that we just filed with the SEC, which is really exciting. That's a major milestone for us in bringing this to reality. But really, with these funds, we expect to have around $300 million, when we go to become a public company. And knowing this is going to unlock a lot of progress for us, pretty significant progress. And yeah, quite honestly, I'm thinking that based on our current projections and internal workings, that this should get us through definitely on getting our license. Like that's my biggest focus is, all right, we probably need to build some sort of demonstration to incorporate data into our license application. And with this fundraise, that should cover everything for us there. So that was really the biggest purpose, was to just accelerate everything. Um, but yeah, I think we're definitely moving very quickly.
Yeah. I mean, that's impressive, right? $300 million injection. And it's kind of that R&D cost to bridge the chasm and get licensed. Yeah, to have a design that can be licensed. And would that be a prototype built, or that's just the licensing activities?
Yeah, so it's interesting. There's the thought of like building a prototype. There's the thought of building like a demonstration unit. What we're looking to do is build a unit that's a little bit over engineered so that we can also sell it to, generate revenue as the first reactor. So these are like discussions that we're having right now on the
Yeah.
engineering team. But yeah, ideally, what I don't want to have happen is we develop this prototype, or sorry, we develop a prototype that like we basically never use. I want to build something that gets used. So
Yeah.
that's really what I'm shooting
It's
for.
a more efficient use of capital, right?
Yeah, exactly.
Hey, we just spent a bunch of money building a shiny toy. Like,
And
anyone?
now we need to raise more, Yeah, exactly.
Um, well, and I guess the next step after that, would you guys be thinking like project finance, just on kind of business model of like, okay, well, we did the R&D work to get it licensed, and now we got to go build new systems. Like, does that
Hmm.
300 million give you enough dry powder then to build your first next system, or you got to like bring in more financing for that? And is that going to be debt financed? Or, I mean, I don't know. And you could say, Mark, great questions. I don't know. We actually have thought about these things. We'll figure it out. But
No,
yeah.
we have thought about these things, and um, where we stand today, the 300 million should enable us to actually build subsequent plants. Um, and we are looking at project finance, for example, and you know, it also comes down to getting these like signed binding agreements from customers. Once we have those, like getting financing is going to be very straightforward, honestly, especially if they're like AAA clients, like we're saying, like someone who's very creditworthy. Um, that's basically what we're working on. But yeah, it's a very important point is like, okay, what's after the first one?
And you said, it'd be great to build something to sell. Is that your vision, that you guys are kind of the original equipment manufacturer, and then you sell these things off, and then someone else goes in and owns them and operates them? Or
So our model right now is Hadron wants to be the owner operator. Um, whether that means in the beginning we partner with somebody to like operate the reactor, we will still own it and just sell the power. So that's basically what we're looking at right now. And then, of course, as you grow the organization, the more like vertically integrated we can become. Manufacture fuel, operate in-house, all these different things, manufacture in-house. Like this could be a massive organization, over time.
yeah, yeah. need enough money to do all those things along the
Yeah,
way.
it's absolutely.
Um, dude, going from South Dakota to New York City, like, where'd you go to school?
I went to Nebraska, so
Okay.
University of Nebraska,
That's right.
Lincoln.
You said that. Yeah. Far
Yeah,
enough, similar to me, far enough away from your parents that like, I could still go home on the weekends if I need to, but
yeah.
I want some separation there. Yeah. Yeah. Yeah.
Mhm.
How's the transition been to big city life and growing this company? Like,
Yeah. No, it's a good question. I mean, for me, it's like I'm definitely just a big city person. I like being in the city. I grew up in Sioux Falls, which is about 200,000 people, and it's not like necessarily huge by any means. It's um, I would say a great place to grow up, but I always knew as soon as I graduated, I started actually Hadron in the Bay Area. That's always where I wanted to start. And then as soon as I felt it was at the proper phase, I would make the jump to New York, which I recently did, of course. And yeah, I'm a huge fan of both places. It's great. Um, we're finding some excellent talent, just making a lot of progress in general. So um, that's what I really enjoy. So I'm happy with the move, and it's going very well.
do you think like fundraising efforts have been easier in New York than they would have been in SF or somewhere else?
It's a good question. It really depends because the thing is, a lot of venture capitalists in the Bay Area are focused on like software. They want to invest a really small amount and see like 1,000x
Yeah.
in like a year or two, and it's just like
Show us your
pretty.
book report. Give us 50% of your company, and here's a
Yeah,
check for
50%.
$500,000. Like,
Exactly.
you're
500,
like,
like that
what?
doesn't get you far at all in this industry.
Yeah.
So yeah, we actually, took a different route, and like the venture capital scene was not ideal. And generally speaking, I think maybe, it's not the best model in general, I think, for just financing a company. I think more on the lines of starting with friends and family, then raising from angel investors until you can start getting into larger, like institutional money. That's where it's at. Um, because yeah, it's just much better, and that's the route that we took, and yeah, it worked out pretty well.
Awesome. Awesome. Um, so are there things that you're afraid of, like big risks, and like what keeps you up at night?
Well, I could tell you that the thing that used to keep me up at night was, you know, working on the very high priority tasks for um, filing, all of our important documents and just closing the
Just
SPAC
fundraise.
deal,
Yeah.
of course, the fundraise. That was like my most important objective, and I wanted to make sure it all went very well. But now that we're past a lot of the big milestones, I'm more so focused on just growing the team as much as I can right now with the folks that we need to hire. And then other than that, I'm I think sleeping pretty well, which is great. But there'll probably be something down the line that, you
Yeah.
know, I have to concern myself with. But for the time being, like, I think we're making a lot of great progress, and we've learned a lot as a team. So we're making, yeah, a lot of great traction here.
Nice. That's awesome. You mentioned that speed to market is important
Mhm.
to you and paramount. Um, are are you guys participating in the DOE's OTA model? No, you
No,
weren't with that.
yeah, we decided to not participate in this because we viewed it as a distraction, to be honest with you, because ultimately you need to have an NRC license that still hasn't changed. The NRC license is how you can deploy a reactor, so that's why we're solely focused on, all right, let's work with the NRC. Um, Well, I'm appreciative of the effort, the DOE is putting in. I think it's great. Um, I think we are as a company, I want to prioritize however, like what it takes to get to the market. That's what we're prioritizing. And right now that's, obviously being collaborative with the NRC. So that's what we're focused on.
Gotcha. Just clarifying a few of those, like the DOE's program would allow you to take a reactor critical, but doesn't allow you to sell
You
electricity,
can't sell power.
right? You
Yeah,
can't. So to have a commercial reactor, you still need an NRC license, right?
that's correct. Yeah. Yeah, you can only go critical. You can't sell power. Um, Basically, the whole thought process behind it is, you know, to utilize the DOE's facilities if you need um, to then extract data from the testing that you do and put that into your NRC license. That's literally all it is. And for me, we're looking at just having our own facility. We control our own destiny. Um, that's basically, yeah, what we're looking at.
Have you guys selected where that facility is going to be?
We're in the selection process right now, so that's another thing that's a very fun thing.
You going to pick
Yeah.
Colorado and come out skiing with us? Like,
So yeah, we've narrowed it down to a few states. We'll be able to share a pretty exciting announcement there soon, but unfortunately, Colorado's not in the final list. But I would still like to, hit the slopes. I'm a snowboarder though, so
you're
I
like,
don't know if that's a
I'm skiing with you, Mark. Yeah. Nice. See,
yeah.
if you're watching online, I got my little Colorado sweatshirt on today. So yeah, yeah,
Yep.
cool. And you guys probably haven't, uh, shared first deployment locations or anything like that. But are there certain things when you're thinking about like first deployments and siting and where to go and do these things that come to mind or are priorities? Like how do you down select? I mean, one of
Yeah, I
the
mean,
beauties of like nuclear is, you presumably could put it. I think you can put it almost anywhere in the world. Not everyone
right.
agrees.
Yeah, I mean, it's interesting. I think one thing that on that comment is you have to be very cautious of, well, what about the surrounding community? If the surrounding community does not support like a reactor, you won't be able to put it in that site. So out of the US, I
Just go
believe
talk
the
to
last
them,
time.
Sam, and we'll convince them that it's okay. Like,
Yeah, I know the more that we deploy, and I'm hoping that the sooner we can get one out there and just show how the thing works, the more support the industry will have to continue more deployments. So yeah, I think there's like the last time I checked about 19 states that are very pro nuclear, and we can have deployments there, of course. Um, but there's a lot of like various things to look at when selecting a site. That would be my first thing as well. Is the community going to support this? The second thing would be, well, what are the like site characteristics? And the nice thing about microreactors is you actually have a very limited environmental impact review with the EPA. Given there's basically very minimal environmental impact that the microreactor has. So that's something that's really great for us because it reduces the timeline. Um, the next thing is,
meaning
you
like
know,
it may not trigger NEPA or
when we say this, like the microreactor has just such a small footprint. For example, one of our reactors sits on zero point 0.6 acres of land. If you compare that to like a full scale reactor that needs obviously an environmental review, it takes up far more land than zero point 0.6 acres. So that's why they have to, conduct the review is, you look at the amount of land you're using, you have to look at all the effects and everything. Um, so that's something that, our design benefits from
well, I
is
mean,
actually
like
having a,
microreactors just there's so little fuel, right? Like
Yeah.
the quantity of hazardous material compared to an oil well, frankly, or a large nuclear power plant, even is just de minimis. I
Mhm.
guess you guys, you said you're using like standard fuel or LEU plus,
Right.
like standard fuel rods, standard fuel bundles, like.
That's right. Yeah. We're using standard fuel rods, fuel bundles, and yeah, the suppliers that we have, they produce them today, so we can access these.
Yeah, it's yeah, just the total quantity of material. I mean, Kugelmass talks a lot about this in like some of the videos that he's got. It's like, guys, this is there is no hazard.
Yeah.
Not no
Yeah.
hazard, but like very, very small hazard. So,
Hmm.
um, cool. Sam, what else? What else is top of mind to you?
Yeah, for me, I'm really focused on obviously the fundraise that we have going on in um, becoming the first publicly traded light water microreactor, which will be the first half of Q1 2026. So it's really coming up. I mean, I know it's almost Thanksgiving, and then Christmas is right around the corner, and then we're going to be right there. So um, yeah, it's coming up very quickly, and I'm very excited about it. So a fun fact for you will be I'm going to be the youngest founder and CEO to ever take a company public. I think the next youngest was 26 with Snapchat. And I'm currently 24, which is pretty exciting.
Nice. Yeah.
Yeah.
Humble brag there. Like,
Yeah. No, it's something I like to share because I get asked every day of like, well, how long have you been doing this? And yeah, it's just something I like to get ahead of it because like everybody asks me. But it's good. I like it. Our team has over 150 years of experience in the nuclear industry. We're continuing to hire um, very strong candidates. So these are the types of priorities that I have is putting the right team in place. And that's what we're really focused on right now.
nice. Cool. Why, so being, yeah, let's build on that a little bit more. Like being so young, what do you think gave you either the ability or the gusto to go and do like maybe
Yeah.
ignorance is bliss, right? Like, I don't know how hard it's going to be, so I'll just jump in.
Yeah, no, it's fair. And, going through my first startup, I learned a lot, just how to approach building a company. And uh, I had a lot of lessons learned because, you know, what we're doing here is obviously not easy, but I figured, and this is the way I think about everything is obviously anything worth doing is really hard. So, um, what we're doing right now, I do believe is very important work. I care a lot about decarbonization, and I think clean energy is probably the most important thing to our future. So if I could contribute to that, I think that would be amazing. I thought as well, like this is the time of my life of where I can work like if I need to. And I feel like this has actually happened sometimes. I can work like 16-hour days. But, if I'm much, much older, I might not want to do that, at that time in my life. So like this is the time in my life to where I want to chase those really big goals and see how far I can push it to then see what we can accomplish. So that's why I thought this was the perfect timing. And yeah, I'm really excited about it.
So let's see. I like to ask the question, where do you see the industry going the next five
Hmm.
to 10 years? But I'm gonna specialize it for you. What is Hadron going to accomplish before you're 30?
Oh, that's a good question. Yeah. So before I'm 30, so it'll be like 6 years, we'll say the things that I want to accomplish are we're going to have our license. We're going to have the first unit deployed generating revenue. we're going to have like the world-class team that can support all this work. And really, if we can accomplish just those three things alone within the next 6 years, I mean, that is a very monumental achievement, given there's still not a single licensed microreactor. And if we're able to do that relatively soon, within the next 6 years, and have revenue generation, that is, I think, incredibly impressive. So I would just focus on those three things. And, anything outside of that, of course, we can probably squeeze more things in there, but those are the top three for me.
Ambitious goals. Yeah, we'll stay focused there. So
Yeah, exactly.
nice. Sam, it's been fantastic to chat with you. Thanks so much for taking the time.
Yeah, thank you, Mark. This is great.